Hello students. In this video, we are going to study what are independent events. Now, as you saw that in the multiplication theorem or the conditional probability, if you say that if event A occurs and event B occurs, what is the probability that both the event occur? When you are considering without replacement, there is a condition wherein the sample space is it is keeping on reducing. Okay. Now, in such case, if event A occurs first, into then probability if B depends upon A. If A has already occurs first, then probability of A intersection B is P of A into P of B provided A has already occurred. Okay, if A occurs first, but if B occurs first, okay, if B occurs first, then first probability of B occurrence into probability of A occurrence provided B has already occurred. So this is what last time also we have seen how multiplication theorem was getting derived. Now, because of this, we arrive at a conclusion. We arrive at a proper discussion that suppose B and A are independent events. Neither B depends upon A nor A depends upon B. In that case, we can say that P of A by B is nothing but P of A, and P of B by A is actually equal to P of B. This is called as independence. Independence. If A and B are independent, then P of A provided B has already occurred. Even if B has occurred first, you will not find any difference between P of A and P of A by B. They will occur independently. So in such case, when you use these two equations here, you will understand that P of A intersection B becomes equal to P of A into P of B, which is equal to P of B by A. So now P of B by A can be written as P of B because the given condition A does not affect the event B. So indirectly, I mean to say that when A and B are independent, P of A intersection B is always equal to P of A dot P of B. Okay. In the same way, if A complement and B are they are independent, still then also P of A dash. Please remember, if A and B are independent, A dash B is also independent, also a pair of independent events, and A, B dash are also independent events. Dot P of B dash. You can prove that probability of you can say that probability of union, like you can prove like this. Say for example, P of A union B is what? P of A into P of B. This is intersection when A and B are independent events. But can you show that? Can you show that P of A dash intersection B dash is equal to P of A dash into P of B dash? Can you show this? It is so simple, students. We must understand that A dash intersection B dash is actually A union B the whole dash. This is De Morgan's law. Therefore, probability of A dash intersection B dash is equal to probability of A union B the whole dash. But we know very well that probability of any complement of an event is 1 minus probability of that event. So here also 1 minus probability of A union B. But what is A union B? 1 minus P of A plus P of B minus P of A intersection B. So minus P of A minus P of B plus P of A intersection B. But P of A intersection B is nothing but what? plus b of a dot p of b. So if you consider 1 minus p of a, then minus p of b, if you can take out common, then 1 minus p of a, this is equal to 1 minus p of a into 1 minus p of b, which is nothing but p of a dash dot p of b dash. Like this you can prove it. ठीक है. So this is what a short explanation for independent events. For numerical examples, we will go for more problems in the next video. Thank you, students.